Hello, everyone, and welcome. Today, I'm going to talk about scalable by design. We are going to talk about how to build scalable and elastically scalable infrastructure. My name is Farhad. I've been in the industry for the last 10 years and been working with Agile to build the scalable infrastructure that we have right now since 5 years ago, since the beginning. In our line of work, there are good days and sometimes bad days. Hopefully, after this talk, we will have some takeaways that help us to be more like in the good days. I will first start by giving you guys an intro to Agile and how the business at Agile works. And then we will talk about our infrastructure and how it will evolve or how it evolved over the years. And afterwards, we will talk about some key learnings that we had. We will shortly talk about application and infrastructure design. And then we will have like a deep dive into our current infrastructure, the migrations that we are doing, and how it actually works, why we are taking the decisions that we are taking, the mistakes that we had, and how we are solving them. In the end, we will talk about hyperscalers versus self-managed services, pros and cons, and then we will finish up. So about Agile, it's a fast-growing ad tech company. We have smart solutions to show personalized ads to our users. We got founded in 2018, and since 3 years ago, we are profitable. We are doing business in 190 plus countries, and we have users from them. And currently, 65 people work at Agile that are coming from 25 different countries. So we are highly international workplace. We have more than 3 billion requests daily, and our backend and infrastructure is supporting that currently. About the business, we have two sides of the business. We have the advertisers and app publishers. On the advertiser side, you can think about any app like Candy Crush that wants to get new users, meaning they have like ads that they want to show in other apps. And app publishers are any other apps that have the users and want to make some revenue off their users. Okay, enough about the business. Let's get into the infrastructure. So our infrastructure has evolved since 5 years that we started. At the beginning in 2018, we were 5 people. We tried to get things up and running super quick. And yeah, we started using one of the hyperscalers, which is AWS in our case. It's great to get things up and running. And yeah, with those 5 people, we did the backend, we did the infrastructure, and kind of everything. We made also a lot of mistakes. At that point of time, we didn't have any clients. And then in 2020 and 2021, business was growing and business was growing rapidly. So we had much more traffic and we had to scale. And then we figured out a lot of bottlenecks that we had, a lot of decisions that we took that wasn't working at the time. And we had to also invest a lot in observability, meaning that we wanted to figure out what is wrong with our infrastructure. We wanted to figure it out quick and we wanted to fix it. Right now, the mission is clear to us. The business is growing even faster, and we want to serve 500 million devices worldwide soon. That means that our infrastructure needs to scale even harder. So what are the challenges for scalability for us? So first of all, we have a massive user base growing every day, and the mission is clear that it's going to be 500 million devices worldwide. Our demand is increasing, our users are increasing, and also the business is growing. And also, we work with a lot of third parties, and those third parties have their own SLAs. That means we need state-of-art application and infrastructure with, for example, high uptime, low latency, and all the SLA expectations that the third parties have from us. And also, we can also throw a lot of money at our infrastructure and break the bank, but we don't want to do that. So we need to have a cost management strategy in mind. let's shortly talk about the 6 key learnings that we had. So first thing that comes to my mind is that, okay, we always think about using managed services versus self-managed services. For example, when we started, as I mentioned already, we were 5 people. We couldn't build the stuff on our own always. We wanted to get into the market super quick with an MVP and see if it works. At that point of time, it was really sane for us to use one of the hyperscalers and just get up and running. Yeah. But currently, as I will deep dive into the infrastructure later, we are using a lot of self-managed services, and I will mention why. The other thing is that while you're getting a business rolling, you're making the infrastructure, you're making the backend, you will make a lot of mistakes, and that is okay. Yeah, it's unavoidable in some cases, but the main idea is that you will learn from those mistakes, you won't repeat them, and you will continue with a better design. Other thing is that we always had our developers super close to our DevOps engineers and our infrastructure managers. Why? Because we want the developers to understand the infrastructure, to see how the infrastructure scales, and also we want the infrastructure managers and DevOps engineers to understand how the backend works. These two type of people complement each other in a way that make our infrastructure scalable with our backend. Meaning, we don't want to scale the backend without infrastructure being scaled, and we don't want the infrastructure scale and the backend will not scale. You know, it's very important to these both sides to scale together. Network traffic we can't really undermine, meaning that a lot of businesses undermine network traffic, and later on when they scale, it will be one of the bottlenecks. But it's really easy to think about since the get-go. So this is one of the stuff that usually needs to be taken care of. Of course, on Kubernetes, it gets even more complicated. Even a single extra hop matters when you scale. Cloud security is really important, of course. Rule of thumb is that everything should be private, nothing on the public internet, unless it's needed. Also, if you're using one of the hyperscalers, for example, like AWS, you can have some services that they provide, for example, inspector and also guard duty that show your attack surface to be able to take control of that. And of course, this is one of the principles of the DevOps engineering, and anything that can be automated should be automated. I put this here to emphasize infrastructure as code and how important it is. It's really important to us, and we use Terraform mostly to manage our infrastructure, and also 99% of our infrastructure is already on Terraform code. It could be that many people think for an MVP, you might not need to use infrastructure as code, but as the time goes on and the business grows, it will save your sanity. So let's talk a little bit about application and infrastructure design and how we do it. For application, we develop our application in microservices design. We try to make sure that our microservices are really not depending on each other. We use event bus and asynchronous communication between microservices to be able to scale easier, and also our microservices are stateless. We try to abstract the business logic from infrastructure, meaning that the business logic should be contained so we can swap infrastructure with minimal changes when we need. And you could go one step further after this. You could also use some tools like Dapper that provide you APIs that are generalized, and then they abstract the infrastructure for you to be able to be cloud agnostic. Let's talk about our Go application. So our applications are two types of applications. One type of application, microservices, will actually receive an HTTP request from the clients, will execute some application logic, and in the end, they could produce some events to the event bus and or persist some data or some state on the database or object store. The second type is the consumer applications that we have. They consume from the event bus. They again launch an application logic and execute it. And afterwards, we will have again some events to the event bus published or persist some data to the databases that we have or to object store. And we are using Golang as our main development language. It has a good balance over maintainability, simplicity, and also it's really easy to learn. Also, the runtime performance is great. In some cases, if we don't need, if we want to have like real-time applications, for example, the garbage collector times are important, we also use Rust. We have a couple of microservices there. And let's talk a little bit about our infrastructure, have a deep dive, and have use our infrastructure as a case study to see what happened during the years. So this is the whole infrastructure that we are managing right now. I know it's like a little bit complicated here, but I will break down each parts and then we will discuss them and you see what parts are we using, what services we are using, and how we are changing or migrating from one service to another and why. At the top side, we have the client facing. You see the user. We have two types of users. As you saw on the business, we have majority of our users are mobile users on iOS or Android. If iOS, we use Swift. Android, we use Kotlin to develop our SDKs. And they communicate to the backend with gRPC or HTTP, JSON over HTTP and HTTPS. We have on the right side the management users that they access our dashboards that we have to monitor their campaign, for example, see a lot of statistics, graphs, to be able to manage their campaigns, and also SDKs on the publisher side to see their revenue and all the KPIs. All the requests from these two kind of clients come to the client facing. At that point, we enter our infrastructure. And if it's a static resources like images and videos, we just use our CDN, which is CloudFront, to respond. Or if it's an API call that needs to reach one of our microservices, we have a load balancer that receives that, and it's like an application load balancer, and routes this to the backend. The whole backend consists of the main parts, at least compute and database. The compute is usually the stateless part, and we store the state on the databases. For the compute, we started with ECS. It's really easy to get up and running, and it's like a container orchestration platform from AWS. And now, currently, we also use EKS to host some of our stateful applications, and in some cases, some of our backend stateless applications. Both these container orchestration platforms are backed by EC2 instances. We only use Spot instances, and I will discuss them later. And we have auto-scaling on instance level and also container level. We have a lot of Lambda functions for management purposes mostly, and in some cases, when we are bringing the data into the data lake, we do some transformation there. Let's go to the databases. We use a wide range of databases. The first one is MySQL over Aurora. It's, I think, one of the industry standards for row-based databases that we are using. We only use it for management data right now, but previously we were using it also for storing statistical data, which quickly we figured out that it's not really good in that use case, meaning that we had a lot of data coming in, and also we had queries with a lot of group by criteria that we wanted to produce graphs, and the database got slowed super quick. From that point of time, we migrated all the statistical data to a columnar database from AWS Redshift. In order to do that, we had to do a lot of pre-aggregation over our data, and then also we should have a lot of jobs that squash these rows per day to make the data smaller and save our costs. But after some years, we decided to also migrate from Redshift to Druid. Druid is a columnar database also from Apache Foundation that is open source. We currently deploy that on our Kubernetes cluster. and the migration from Redshift to Druid is ongoing. Druid has this nice feature called rollups. That means that on the database layer, you can do all the aggregations and all the squash jobs, and you don't need to develop them yourself. Let's talk about DynamoDB. DynamoDB is a NoSQL database from AWS that we are using. Usually the APIs that are facing the mobile applications are storing their state there because it's highly scalable and it's really easy to manage. But now we are also using a database called Scylla. It's a Cassandra-like database. We deploy it on our EKS cluster. And we are moving some tables to Scylla in order to save cost. So now that we have more expertise, we want to migrate from some of the AWS services that we are using to the others in order to save costs and have more self-managed services. And also, we have a lot of Redis clusters. Previously, we only had one, and we learned it the hard way that we need to separate our domains of failure. Meaning, whenever a microservice right now needs a Redis cluster, we create a smaller Redis cluster for that microservice, and we don't mix them together. Of course, I talked about observability. We should talk about 2 out of the 3 pillars of observability, which is logging and monitoring. For logging, we have FluentBit as a log shipper. We ship our logs from ECS clusters with FluentBit to Elasticsearch clusters that we have and Loki clusters. In ECS, it's like a sidecar next to the tasks. And also on Kubernetes, we have it as a daemon set and sending the container logs to those log storage backends. We use Elasticsearch for our recent log data because it's easy to query and also it's super fast. We deploy our Elasticsearch clusters on Kubernetes ourselves, and we also, again, have Loki clusters on Kubernetes with S3 backends as storage to store longer amount of data for logs. So if the developers need older logs, they can access them as well in a cheaper manner. For monitoring, for AWS, we use CloudWatch, and we have a lot of alarms and metrics there. For anything other than AWS services, we use Prometheus and Kubernetes. These can be all the open source technologies that we are using, and also our business metrics. We have Sentry for application critical errors, and we have also alarms there. And we have a third-party incident manager that is Squadcast. On Squadcast, we have some webhooks that trigger a Lambda function and route the alarms to the correct team. Let's talk about Event Bus, Data Lake, and machine learning platform that we have. For the Event Bus, we started with SNS and SQS in the beginning. These are like 2 standard AWS services. For inter-service communication, we used to use them heavily. And after a while, we started to deploy our own Kafka cluster on Kubernetes. Now we are in the process of migrating some of that messaging between the services from SNS and SQS to Kafka. Of course, it's not easy. We need to change our backend in a way that supports some features or even develop some features that are not supported by Kafka and are supported by SNS and SQS, but we get much cheaper event bus there. We have Kinesis and Kinesis Firehose to stream our data to our data lake from the backend services, and we are replacing that also with Kafka. We have a stream processing platform as well, a real-time stream processing called Flink that we also deploy that ourselves on Kubernetes cluster, and it's hooked to Kafka and does some stream processing and then syncs the data to different backend like Redis and S3. For the data lake, the main part is S3, of course. We store the files in a columnar format called Parquet, and then we query them with Athena and Spark clusters that we have. And also we have Apache Hive Glue from AWS for our metadata store, meaning that we have crawlers that crawl the data and also store the column information in table format in Glue that we can query them with Athena and Spark. For machine learning, We use Airflow on Kubernetes. We use Spark operator on Kubernetes to submit jobs from the DAGs. And also we have MLflow for our experiment manager and model repository. We use Jupyter with Spark and also Zeppelin with Spark. And we recently added Dask to the mix for special jobs. I mentioned the Spot instances, and we are using Spot instances everywhere. These Spot instances from AWS are key for us because we reduce our infrastructure cost by more than 60%. So how do we use them? These Spot instances are the extra capacity on AWS data centers. And AWS lets us bid on this extra capacity. And usually they would be much cheaper than on-demand instances. But they come with a caveat, meaning that AWS will take the Spot instances with a 2-minute notice when somebody bids higher or the capacity is not available anymore. It's like some sort of chaos engineering in production, yeah? So your instances can pop away in a blink of an eye, let's say. But your backend developers should react to that by designing the backend correctly, and also your infrastructure managers should design the infrastructure. As I mentioned, we run a lot of databases, Kafka clusters, everything on Spot instances. So you should be ready. Your design should be ready. Let's talk about hyperscalers like AWS and compare it to the self-managed. As I mentioned, your development speed on the hyperscalers would be super fast. So you can get up and running super quick because everything's ready. You just need to know the services and start using them. You don't need many people to manage these services because hence they are self-managed. And they are standard products, meaning that you can switch from one hyperscaler to the other hyperscaler and also know a lot of services. We have some cons though. First of all, you get vendor lock-in, meaning that when you're using one of these hyperscalers and then you grow, your application grows, your business grows, you cannot really change easily because you're super dependent. The other thing is at the beginning, the costs are like super cheap. You pay as you go. You don't have much traffic. It's super cheap and convenient. But when your business takes off, these costs explode. Other than that, for some advanced use cases, for example, remember our Druid use case with Redshift that we had to develop a lot of stuff on top of. Redshift, to be able to use it, was not there. So if we use Druid, we don't need to develop a lot of stuff ourselves. It would be much easier for the backend developers, and we would be much quicker. So these limitations are also there. But we can recommend some of the AWS services if you're just starting. For example, ECS is super cheap and also super convenient to use. You can get up and running super quick. If you're using it with Spot instances from the beginning, it would be even cheaper. S3 is industry standard, and I just don't need to talk much about it for object storage. All the cloud providers have some sort of S3 object store, and you can also have some open source projects and deploy the S3 API on your own. EKS is really important because you don't need to manage your control plane of the EKS clusters, and you can have Kubernetes clusters up and running super quick with some clicks, and it's also super cheap. And the last is AWS Glue as the meta store. Glue crawlers come in handy, and also the tables that you have and the amount of data that you can query with Athena chip is really cool. About our strategy, we want to be cloud agnostic by the end of 2024, and I guess you guys now notice why we are doing this, so it's clear. In order to do so, we need to replace some services that we are currently using. For example, we are going from CloudWatch towards Prometheus, from DynamoDB to Scylla, from SNS, SQS, Kinesis, and Firehose to Kafka, and from EMR On AWS, we are going to Zeppelin and Jupyter and Spark Operator on Kubernetes. For some closing thoughts, first one is like there is no silver bullet. You need to check your business. You need to check what point in the time you are in your business and act accordingly. Everything is a trade-off, meaning that we are just making trade-offs when we are thinking about, for example, self-managed versus managed services, which cloud provider to use, which services to use, how to develop the backend. Every day, you will deal with trade-offs. After your business grows, the costs explode. And that means we need to keep in mind what kind of replacement of the services we can use. Yeah, we got up and running. Now the business is growing. Now we need to think about how we can have a balance to not break the bank. And we don't believe in one vendor dependency because we want to use the best-in-class software in our infrastructure. Thank you.